Here we go. We are going to look at 3 questions here, one factoring question, the same factoring question using the quadratic formula, and finally a factoring question that is going to incorporate imaginary roots. Okay. I would like you to try each question as they come on your own. Give it an honest shot. Pause the video. If you get stuck, go ahead and keep playing and I will have the worked out solution. But make sure that you can do all 3 of these questions on your own before you shut down the video entirely. So here we go. First question, we're going to find the roots or the zeros, right, where this graph crosses the x-axis. And then we also want to consider where this graph might cross the y-axis. Okay, so here we go. Right, so we want to factor the right side of this equation. We want to find 2 numbers that multiply to 5 but add to 6. Pretty easy. You know that's going to be 5 times 1. 5 times 1 is 5. 5 plus 1 is 6. It doesn't matter where I put the 1 or the 5, right? If I FOIL this back out, I'm going to come with the polynomial that I began with, right? Now that I have it in factored form, it's easy to find the roots. The roots exist where each of these terms equals 0, right? So x plus 1 equals 0, x plus 5 equals 0. And so this graph crosses the x-axis at x equals -1 and x equals -5. I can start to plot that. X equals -1, x equals -5. You might notice that, well, what I've done here is I've set y equal to 0. Why? Because y equals 0 all along this x-axis, right? The value of y equals 0 everywhere along the x-axis. So if I set the equation value for y equal to 0, I am finding where this quadratic crosses the x-axis. It's especially easy to find where that occurs if I have this quadratic in factored form. And we can see that the y value will equal 0 if x equals -1 and if x equals -5. So y equals 0 at both of those locations. Next, I might consider, where does this graph cross the y-axis? Well, all along the y-axis, my x value is 0. So instead of setting y as 0, I'll set x equals 0 to our original equation. When x is 0, y equals 5. And so I know we're going to cross the y-axis at y equals 5. This helps with my graphing because I know my graph must cross through all of those points. Right? Okay. We're going to solve the same question, the same polynomial, using the quadratic formula now. So we had y equals x squared plus 6x plus 5. And I know we already know how to do this, and yes, it's much simpler to use factoring, but in order to know how to use the quadratic formula for when it is necessary for some more complex factoring, it's good to use it to try it out. You might as well go ahead and memorize this equation. It's going to stick with you for a while. And, well, a general form of a quadratic is some number times x squared plus some other number times x plus c. And so there's those coefficients. That's where our a, b, and c come from in this quadratic formula. We want to check those coefficients out here. In this case, a equals 1, b equals 6, c equals 5. Okay, so we're going to plug those values in to our quadratic formula. Negative b is negative 6 plus or minus 6 squared minus 4 times 1 times 5, all divided by 2 times 1. We get negative 6 plus or minus the square root of 36 minus 20 divided by 2. This leaves us with negative 6 plus or minus the square root of 16 over 2, or negative 6 plus or minus 4 over 2. Great. Now we need to split this into the two scenarios that it's prompting us to do, right? Negative 6 plus 4 divided by 2, and negative 6 minus 4 divided by 2. So this gives us negative 2 over 2, or negative 1. And here we get negative 10 over 2, or negative 5. So what does this tell us? Well, x, right, the 0, the location, the x location that this graph will cross the x-axis occurs at negative 1 and negative 5, just like we found here, right? X equals negative 1, x equals negative 5. Same question, different technique, same solution, right? We could go ahead and graph that just as we did before, but here we're simply showing how to use the quadratic formula. Finally, we're going to use the quadratic formula one more time, and this is where it's really relevant. Here, we don't know how to factor this, right? We try, and we need two numbers that multiply to 5, but add to 4. And that's just not possible, right? 5 times 1 is 5. 5 plus 1 is 6, right? We're not going to achieve the result that we want. So our regular factoring technique is not going to work. Here's where the quadratic formula comes in handy. So again, might as well go ahead and memorize this. It's going to hang around with us. Again, we can check our A value, our B value, and our C value from our specific question here, right? And we can plug and try and solve. So x equals negative 4 plus or minus the square root of negative 4 squared, not negative 4, 4 squared, minus 4 times 1 times 5, all divided by 2 times 1. So we have negative 4 plus or minus the square root of 16 minus 20 divided by 2 equals negative 4 plus or minus the square root of negative 4 divided by 2. Oh no, right? We cannot take the square root of a negative number. And here's where the complex numbers, or the imaginary number I, comes in handy. Remember, I is equal to the square root of -1. That means I squared equals -1, right? I cubed is I squared times I, so it's -1 times square root of -1. We call that negative I. I to the fourth equals 1, right? There's kind of our rules of I, and it's going to come in handy here because how do I deal with this square root of -4? Well, square root of -4 is equal to the square root of -1 times 4, or square root of -1 times the square root of 4. That equals I times root 4, or 2I, right? 2 times I, right? So with that in mind, we're left with -4, defaults back to that thickness, -4 plus or minus 2I over 2. Now we can split this into our two scenarios. We have -4 plus 2I over 2, and we have -4 minus 2I over 2. I'll just write them down here. -4 plus 2I over 2, -4 minus 2I over 2. Right? When we have two terms on the top separated by addition or subtraction, one term on the denominator, we can split this. -4 over 2 plus 2I over 2, -2 plus I. Similar here, -4 over 2 minus 2I over 2, and we're left with -2 minus I. So here are our two solutions. Now we are in the complex plane, right? We are no longer on the XY axis. We're now on the imaginary real axis. We're on the complex plane, and our results, our answers, end up in the form A plus BI. That's the complex number, right? Real term A, complex term BI, 1 times I there, right? Real term -2, complex term BI, -1 times I there, right? And so there we go. We start with something that we do not know how to factor. Fortunately, we have the quadratic formula. We run into an issue when we're being asked to take the square root of a negative number, but we introduce this complex, this imaginary number I, which allows us to move forward. Finally, we get two solutions: x equals -2 plus I, or x equals -2 minus I.